Here I am assuming some familiarity with categorical statements and the arguments that can be formed by using categorical statements, categorical syllogisms. And we're going to look at how to evaluate these categorical syllogisms, how to evaluate their validity by using Venn diagrams. And Venn diagrams are interlocking circles. So categorical sentences, the kinds of statements that are used when forming a categorical syllogism, can be represented visually by these interlocking circles that we call Venn diagrams. And each of the four types of sentences, the A, E, I, and O sentences, can be represented in a particular way with a Venn diagram. Now, once we are able to do that, we can check the validity of a categorical syllogism through the use of Venn diagrams. And when we're evaluating the validity of categorical syllogisms, we're going to use three interlocking circles, as we will see. So we start by showing how the individual sentences are represented. Now, there are different methods of doing this, but I'm using a method by Marilee Salmon and following her method, which is a very common method. The S on the left there is a shorthand for the subject of the categorical statement. The P on the right is shorthand for predicate of the categorical statement. And here, A sentences are all S's are P's. So, for example, all cats are mammals. And what we do is we shade in all of the area of the subject that's not included in the predicate. So that's representing the fact that there is nothing there. Nothing exists in that subject circle that isn't also in the predicate circle. So there are no cats. Let's reverse that and put that positively. So all cats that exist are within that predicate circle. We can represent E sentences by shading the interlocking portion. So E sentences say no S's are P's. So that means there's nothing that exists in that interlocking area. So, for example, no cat is a reptile could be represented this way. If we have cats on the left and reptiles on the right, we shade in that interlocking area to represent the idea that there's nothing that exists there that fits in both of those categories. I sentences are of the form some S's are P's, and we just use an X just to say there exists something that is in that interlocking area. There are some of the S's that exist that are also P's. So if we had, for example, the I sentence, some cats are striped, so the S would be cats, the predicate would be striped things, and we show that there's something that exists in the interlocking area by putting the X. We also use the X with O sentences. Now, O sentences say some S's are not P's, and so we represent that by putting an X in the area of the subject that is not also in the area of the predicate. An example might be some cats are not striped. So we have the X representing that fact. So all four of the sentences, the A, E, I, O sentence, can be represented in these ways. What we want to do then is use those resources to assess the validity of Venn diagrams. So each type of the sentence that we've seen, the A, E, I, and O sentence, has a particular form of the diagram. The A's and the E's, we use shading. The I's and the O's, we use X's. And then when we are evaluating an argument, we're going to have three interlocking circles. There are going to be three different terms. And it needs to be set up so that both the S and the P terms are in the conclusion, or you might say that the other way around. You look at the conclusion, you identify the subject and the predicate of the conclusion, and then those are going to serve as your S and P terms. And there's going to be a third category that will be included in both of the premises. We call that the middle term. So what we do then is we diagram the premises, and if after doing so, the conclusion can be read off the Venn diagram, and we'll see how that works in a moment, then we can see that the argument is valid. On the other hand, if we've diagrammed the premises and the conclusion cannot be read off the diagram, then we know we have an invalid argument. Okay, so that's the description of what's going on. Let's look at 4 different examples of categorical syllogisms to show how this works. So we set up arguments to evaluate. We have the S and the P like we did for any individual sentence, but we have a middle term now, and so we have that interlocking. So we have the 3 interlocking circles as such. So here's an example of an argument. All humans are mortal. Some mortals are heroes, and some humans are heroes, is our conclusion of this argument. So these are categorical sentences. And what we want to do is to set up the Venn diagram where we have humans as the subject and heroes as the predicate, because we're looking at the conclusion to do that. And then our middle term in this case is going to be mortals, or things that are mortal. And so we set it up like this. We have on the left hand, the subject, things that are humans. On the right hand, things that are heroes. That's our predicate term. And then the middle term are things that are mortals. And now we can evaluate the argument by diagramming the premises. So the first premise is all humans are mortal. So we have, that's an A sentence. So we shade out all of the section of that circle of humans that is not also in the circle of things that are mortal. So that's why we have that area shaded. The second premise is some mortals are heroes. Now note here we have a challenge, a difficulty of sorts, because in the mortals section and the heroes interlocking section, there are actually 2 different categories there. There are 2 different areas where that thing might exist. And so we represent that by putting an X in both areas, but the dotted line connecting the X's shows that it's what we call a floating X. Some systems use an X just kind of on the middle of that line. I think it is a bit more clear to do it this way. And what that means is we know there's an X in one of those 2 categories. It could be both, but we don't know for sure in either of those sections that there's actually an X in that particular section. And so when we get to our conclusion that some humans are heroes, well, there's a floating X in the interlocking area between humans and heroes. So we don't know definitely that that's there. That means we don't know that definitely this conclusion is true. And that means that we don't know if the argument, or rather that means that the argument can't be valid. It's invalid because we have true premises, but we don't know whether or not the conclusion is true. It seems like it could be false. And so if we have true premises and a conclusion that could be false, by definition, that is an invalid argument. All right, let's look at a different example here. So our first premise, some birds do not fly. Second premise, all birds have wings. And our conclusion, some winged animals do not fly. And so we use our conclusion, we have winged animals and things that do not fly, and we want to represent that in a positive way. So we'll say things that fly when we represent the S and the P. So here's how we set it up. We have winged animals on the upper left, things that fly on the upper right, and then the middle term, the category that was used in both premises but didn't show in the conclusion, is the category of birds. So this is how we set it up. Now what we need to do is diagram out the 2 premises and see if we can read the conclusion off of that. Now, the first premise is some birds do not fly. And again, we have this challenge where we have a floating X. We know that there are some birds that exist that aren't in the predicate, but we don't know for sure, if which of those 2 areas to put it in. So it's a floating X. We know there's something that exists in the category of birds that is not included in things that fly, but we, at this point, just by this premise, we're not sure if it exists in the category of winged animals or not. So that's how we would represent it if we did this premise first. Now, the second premise says all birds have wings. And so that means we eliminate that area of the circle of birds outside of the category of winged animals. So we shade all of that in. Now, what that does in this case, it eliminates our floating X. It allows us to know for sure that we actually do have an X in that category of winged animals and birds. And so we know that there are things there that exist. It's outside of the category of things that fly. So, and in fact, in this case, it would be something like maybe a chicken or a penguin, something like that. Neither one really fly. And so we know that there's something that exists there. And our conclusion, some winged animals do not fly. Well, we have something in that category of winged animals that exists outside of the category of things that fly. And so here we know that definitely this conclusion must be true. And that means if the premises are true, the conclusion must be true. So we have a valid argument. Now, a tip on this, you don't have to draw out the premises in the order that they are presented. So this would have been easier to diagram had we just used the second premise first, and we just did the all birds have wings, that second premise, and shaded in that area first. And then when we got to the premise, some birds do not fly, we would know it definitely fit in that category where the X remains here. Let's look at a third example. No cat is intelligent. Some animals are cats. Therefore, some animals are intelligent. Now, I hope just by reading this one, you can kind of see that this is not going to be a valid argument, but let's make sure we show that and think it through how it would be represented with a Venn diagram. So we have the categories from the conclusion. The conclusion was some animals are intelligent. So we have animals as our subject term, things that are intelligent in our predicate term, subject on the upper left, predicate on the upper right. The middle term in the premises that did not show in the conclusion is cats. And so that's the middle term on the bottom. Now we start with our first premise, no cat is intelligent. So the claim here is that there's nothing that exists in that circle of cats and intelligent things. So we just shade in all of that area. And then our second premise is some animals are cats. And here, the only place we can put the X is an area where the animals and cats overlap, but it's also in that area outside of the circle where there are intelligent things. So here, again, we didn't have to worry about the floating X because we did the universal statement, the A or the E sentence, and we diagrammed that first. Now, can we read the conclusion off of this Venn diagram? The conclusion, again, is some animals are intelligent, and we cannot. There is no X there. There's nothing that exists in that overlapping area of animals and intelligent things. There's no X there. And so we don't know. And so if you don't know, that means that the conclusion could be false, which again means that we have an invalid argument. Okay, one more example. Here we are putting our universal claim first, which is going to make it easier to diagram. Every human is important. Second premise, some humans are not famous. And we conclude some famous people are not important. And so our conclusion has as the subject famous people and as the predicate things that are important. So we diagram our Venn diagram to evaluate the validity of this syllogism with famous people in the subject, the upper left, important people or important things on the upper right, and then humans on the lower circle as the middle term, the one that shows up in both premises, but not in the conclusion. So every human is important. We represent that by shading in all of the area of the circle of humans that is not also in the area of important people. So we know that there's nothing that exists in that area. Then we have our second premise: some humans are not famous. And so the only place to put that X that's within the human circle, but outside the famous people circle, is where we've placed it here. So we know that something definitely exists there. And then our conclusion is some famous people are not important. Well, we have an X outside of the category of famous people, but we don't know if there exists some famous people that are not important. We don't know if there's an X in that larger area of the subject circle. So again, we can't draw that conclusion. So that argument is invalid. Of course, it's a lot easier if you get a valid argument and those are clearly demonstrated. But the question again is that, is the conclusion something that is definitely shown by our final Venn diagram? And in this case, it's not. So it is an invalid argument. So that's how you use Venn diagrams to evaluate the validity of categorical syllogisms.